You ready? Let's see how much you remember. Pop quiz. Getting I just. Your eyes going so big. It was so funny to watch. So, a group pop quiz. Somebody tell me, what is the null hypothesis?
Basically what you're testing. Like if you're saying like, oh, I think the mean will be equal to this, like mu equals 150, and then the alternative is the opposite, like not equal to that.
Agree, disagree, want to add to what she said? Yes?
Just add the word assumption. We're checking the assumption. We're assuming something with this and then it's checking.
Okay, so it could be something that you're assuming. It could be something that you're testing. I heard the word equals.
Yeah.
Okay. So our null hypothesis can be represented, say it that way. Big H, little o. Ho. That was good. And it always is an equal sign. Now I say that. There are two, let's say this, camps, if you will, two thoughts about how you write a null hypothesis. Some camps, where I came from, are into the null hypothesis always has an equal sign. There's never an equal sign in the alternative hypothesis, and everybody agrees with that. What people don't necessarily agree on is if all possible conditions have to be met in your null and alternative hypothesis. Okay? So, for example, somebody tell me what your alternative hypothesis is before I make this comparison.
Not equal to, greater than.
Okay, so when we're talking symbols, I'm hearing not equal to, greater than, less than. Could this be the thing you're testing?
It kind of is. Like you're trying to see if you're rejecting a null hypothesis for this new idea, right?
So that will be our ultimate test as we do the hypothesis test. We're either going to reject or fail to reject our null hypothesis. Okay. Setting up our null and alternative hypothesis, the null hypothesis can be a claim that we're testing, is this true? Or we can have it where it's, the alternative hypothesis is what you're actually setting up to begin with. Here's a condition I want to test. So there's lots of different ways that you can set these two up. But the big thing is, your null hypothesis is what we're going to be, never use the word prove, supporting or not, finding support for or not finding support for. Okay? So for me, these right here are the symbols that I would use. As you read your text is of the camp of all possible conditions need to be represented in the null and the alternative hypothesis. So what they would say is that if you are interested in something being greater than, then your null hypothesis should be less than or equal to. How many of you, when you learned the blue camp? How many of you learned the green camp? How many of you don't really remember which camp I was in? It's okay. I don't care which way you do it. As you watch me do things, I'm of the blue camp. I don't think you need to have everything represented because you're going to reject and fail to reject that null hypothesis, and it's going to be fine. Okay, we'll do some examples here in a minute, and I'll show you the difference between the two. So moving on, we're talking about our types of hypothesis testing. What's the difference between a one-tailed test and a two-tailed test? It is that obvious.
The two-tailed to the non-equal and one-tailed to the greater than less.
There you go, right? That's a good way to say it. So the two-tailed, and I'm assuming a normal distribution here. I'm going back to blue because I like them better. Right, so the two-tailed, I'm interested in what happens below and what happens above. Whereas the one-tailed test, I'm only interested in either below or above. And this could be my mean, it could be a proportion, it could be anything. So two-tailed, non-directional. Okay. I don't know which way it goes. It's not equal to. One-tailed, I've got a hypothesis that whatever I'm doing is either greater than or less than something else. We'll put this all together with examples here in a minute. And this is just kind of big picture concepts. What do you guys remember? We're going to test hypotheses. As we test hypotheses, the one word that I never, ever, ever want to see you guys write in my class is the word proof. Okay. We're doing a statistical test. We're doing inferential statistics. We're talking about how confident we are about something happening. Have we ever calculated a 100% confidence interval?
Yeah.
No. 99.7, right? We did that one. Okay, we can get really close. We can have strong support for something happening, but we can never prove that it happens. Because in one other sample, maybe that didn't happen. Okay? And you guys love your word, you guys in general, love to use the word proof. So we don't prove things. We find support, we find evidence. And I don't get really mad about using that word until the very last paper. And then if you use that word in the very last paper, you get an F. I guess. You don't get an F. But I do get he's really good like frowny faces. And because we can't prove anything definitively, there are the potential for errors. Right? So does anybody remember what's the difference between a type 1 and a type 2 error?
Type 1 is false positive.
Yes.
So what's a type 2? False negative. So do we have an example that we can use?
Type 1 false positive would be telling a guy that he's pregnant.
You're good. Was that like totally yours, or did you actually look?
No, I've memorized this from undergrad classes.
That's just like the great example, right? I just happen to have that picture next. Yes, that's exactly what it is. Yes.
Convicting someone who's not guilty.
Oh, convicting someone who's not guilty.
And then the type 2 would be not convicting someone
Who is guilty?
Freddy Krueger style.
Look at you guys. See, I don't need to teach this at all. Okay? Here, I teach you. So type 1 and type 2 error. The easiest way to think about it, and I'll show you the technical definitions here in a second. But yeah, a type 1 error is giving that false positive, right? Telling a guy that he's pregnant. Are you sure that's going to be wrong? Right? Telling the pregnant lady she's not pregnant. Again, probably not. Okay? Convicting somebody who's innocent, right? That's that false positive. Not convicting someone who is not innocent. So not convicting someone who is guilty. Okay? That's the idea behind the type 1, type 2 error. This is the technical piece of it. Okay? So in the population, the null hypothesis is true. So let's come up with null hypothesis. Do you want our null hypothesis to be pregnant or not pregnant? Not. Let's see. So if we're going to do, let's just do alternative. So we've got equals, not equals. Let's go with is pregnant. Or use the equal sign. So our null hypothesis is going to be, oh, you're pregnant. The null hypothesis is, oh, no. Or depending on the case. Yay, not pregnant.
So is the alternative hypothesis always just the inverse of the null?
Let me say that. 95% of the time, yes. Because when you say, I have an alternative hypothesis that the average grade on the test is greater than 70, my alternative hypothesis, you can still write your null hypothesis as it's equal to 70.
Oh,
So it's not always, and that's where that other camp comes in, and they're like, oh, you really should, look at everything else. So another way you could do this is that, and so then it's totally the inverse.
Right.
Or I'm okay with just this piece.
Okay. Is that what you're talking about the blue versus green stuff?
Yeah.
Okay.
And again, we'll do some more examples to help. Writing the null and alternative hypothesis, sometimes it seems really easy and sometimes it's a little more tricky, just depending on the scenarios we have. So here we've got our null hypothesis is that you are pregnant. Our alternative hypothesis is that you're not pregnant. So this situation, so in the population, our null hypothesis is true. Pregnant. Our null hypothesis is false. Therefore, you are not pregnant. If we fail to reject our null hypothesis, that means we're keeping it. We like it. Then what's our conclusion? You're pregnant. And if we reject our null hypothesis, I don't like you, then we're going to keep our alternative hypothesis that you are not pregnant. So if in the population, so if you're actually pregnant, and we do our statistical test, blood test, pill stick, whatever, do your test, and it says you're pregnant, yay! You are pregnant, your test says you're pregnant, life is good. What if you're not pregnant and the test says you're not pregnant? Life is still good. Yay! What if you're pregnant and the test tells you you're not pregnant? Do it again. Do it again. Okay, that's your type 1 error. So when the null hypothesis is true, but you rejected it, and your statistical test says, no, this isn't good, you're not pregnant, then that's what's the type 1 error. Right? That's that, if we look back here, that's that false positive. Right? So said it was true, so that's the positive part. We were wrong, that's the false part. Last option is that type 2 error. So you're not pregnant, but the test tells you you're pregnant. And that's your false negative. Questions, comments, thoughts about that one? Okay. A type 1 error is represented by the letter alpha. Have we seen alphas before? That level of significance ties directly into it. For type 2 error, we use the Greek letter beta. We don't do a whole lot with it. So type 1 error, making a false positive, is where we put most of our effort. Okay, we want to control, as researchers, how willing we are that when something's true in our population, that we're going to say it's false. Alright. What else do we have left? Some more vocabulary. Let me see if you guys know some more vocabulary. P-value. What is a p-value?
Probability that the null hypothesis is true given the observed result.
Yes. So it's the probability that our null hypothesis is true. So, looking at a picture, I'm going to use the mean for my little example. The p-value is this area out here. Probability our null hypothesis is true. we're going to focus on interpreting p-values. Okay? There's another thing called the critical value. And what the critical value is let's say that I want to be 95% confident about my answer. Then I can actually calculate this value right here. And if you can get your test statistic, and we're going to talk about test statistic in a second, if you can get your test statistic in that region, then you get to reject your null hypothesis. Depending on the scenario, everybody's happy. So your p-value is going to go with your alpha level, your level of significance. This is your alpha level. Your test statistic, which is actually going to be, I'm actually going to leave that generic. As we go forth and do stuff for the rest of the semester, we are going to basically be looking at some sample statistic. We're going to subtract either a population value or another sample statistic. And we're going to divide it by some type of standard error. And based on that result that we get, if it is inside our little rejection region, we get to reject our null hypothesis. Or if it's outside our rejection region, then we fail to reject our null hypothesis. Big picture. As you read through your book, this is the critical value approach. We're not going to focus on the critical value approach. To do the critical value approach, you have to have tables in the back of books and all sorts of craziness. We have SAS. SAS gives us p-values. We're going to compare our p-values to our lovely alpha level. And if our p-value is greater than, if our p-value is less than or equal to our alpha level, then we're going to reject our null hypothesis. There's one thing that you remember from today. This is it. Yes.
So, failing to reject doesn't necessarily mean it's true, right?
Correct. I love that you said that. Okay. So your textbook actually uses the word accept, like A-C-C-E-P-T, accept the null hypothesis. I prefer fail to reject. Okay. So I'm not saying that this is it. I just don't have enough evidence to say that's not it. Okay. So I'm not accepting it that it's the truth. I'm just saying that I don't have enough evidence that it's not the truth. The whole innocent until proven guilty thing. You may have committed the crime. I just don't have enough evidence to say that you committed the crime. So looking at our cross-industry standard, looking at our process, our data mining process, where does the hypothesis testing part fit in? Where does the hypothesis testing fit? Say it again. Oh. It could, but I'm going to do it a step further, or a step earlier. So we'll understand our business and research questions. We'll prep our data, or we'll understand our data. We'll prep our data, and actually the modeling phase is where we're going to do our statistics. The evaluation phase is going to be checking to see if our hypotheses are correct, if our results are correct. We'll do our hypothesis there, test there. Later this semester, we'll do our regression analysis there. So inside of our big data mining picture, we have our hypothesis test. And there's actually 6 steps that you're going to follow when doing a hypothesis test according to your textbook. Any ideas what kind of things we need to do?
Maybe hypothesis.
You gotta have a hypothesis. That's probably the first thing you need. Right? We're going to state our null and alternative hypothesis. So we have all this data. So once we have our hypothesis, then what do you think we should do? We have all this data, what should we do with it? Maybe we should calculate something? Okay, so we've done descriptive statistics, so we have some information. So once we move on past that, I heard something. Alpha? Okay. So we need something to compare it to. Right? We need to know how likely are we to compare or to commit a type 1 error. So we're actually going to choose our alpha level. Set alpha. And what do we compare our alpha level to? A p-value. So to be able to get a p-value, this is where we have to calculate our test statistic. SAS will do that for you. So what can step 4 be? Find P. So now we have a test statistic that helped us find the p-value. We have an alpha level to compare it to. What should we do? Yeah, go back to the hypothesis, right? So decide, are we going to reject or fail to reject our null hypothesis? So we're going to call it, make our statistical conclusion. This is our reject, fail to reject. Our null hypothesis. So what do you think step 6 is? Again. Go back to the beginning and put it in terms that people can actually understand. So you could call it a contextual, a practical, a business, a research. There's lots of different words we can use here. Conclusion. Okay. You're not going to go back to your boss and say, hey, I rejected my null hypothesis. Exactly. What? Okay. You're going to go back and say, the difference between these two groups wasn't significant. We're fine. Or our product is way better than the other product. It's better than the national average. And those are your 6 steps. They're more technical in the book, but this is the big picture. Great question. Wonder if you'll see this again.
In textbook form or this form?
Either one will be totally fine because it's a fill in the blank.
Oh, okay.
No, it's not a fill in the blank, it's an essay question. You're just typing it in. So you can write it like this, you can copy straight out of the book, I don't care. Did I give that away? Did I say that was a quiz question? Maybe that'd be a quick
You
question.
didn't say it explicitly.
Right.
I thought I just did. Yes, in the back.
Okay, whether we are rejecting, failing to reject a null hypothesis or whether we are accepting a null hypothesis will not depend on the question. For example, if the question is the person guilty or is the person innocent, which is a null hypothesis. Based on that, wouldn't that change?
Yes. Yes, so if you make your null hypothesis the opposite of what I make my null hypothesis, then our results should change as well. Yes, so if I'm interested in this is less than something, and you're interested in this is greater than something, if we have the same data, I should fail to reject my null hypothesis and you should reject yours.
That's not my question. My
Not
question is
man, I'm not doing good with you at all. Yes.
my question is that we should not even be looking at it as failing to reject the null hypothesis, but rather looking at it as accepting the null hypothesis. And for example, if you're saying the null hypothesis is the person is guilty, then you say that I failed to reject the fact that he's not guilty.
Right.
But whereas in this sense, you say they are accepting the innocence.
So there's a difference in statistical vernacular and legal vernacular, right? So for us, we want to be very specific and say that we fail to reject a null hypothesis. Now, when you go down to your contextual explanation, you can say that we accepted the idea that he's not guilty, and that's okay. But for the research part, we want to stick with directly to reject or fail to reject. All right? Now, I will say, your book, as you read through your book, it uses the term accept. So if you use the term accept, I'm not going to count offer things. I'm just going to tell you that my preference is to fail to reject, because I think it makes more sense. And this is where statistics is fun. If you get it from like a business analyst, or if you get it from a pure statistician, or if you get it from different people in different fields, they'll tell you, kind of teach you different ways. Overall, the idea is still the same. All right, do you have anything left? So the three hypothesis tests that we're going to learn in Chapter 9 are we're going to be comparing a sample statistic to a known value. Okay? So we're going to do, and really, this is in your book, this one right here, and I'm going to show you how to do it. But most of the time, we don't know the population standard deviation, so really, this is the one that I use 98% of the time. But, as this is a pure stat, or this is a intro stat class kind of, I show you both. So we're going to be able to compare a mean to a population value and a proportion to a population value. That's what we're going to do in Chapter 9. In Chapter 10, we'll compare one mean to another mean. In Chapter 11, we'll compare several means to each other. And that's like the next 4 weeks. So each week, we'll just kind of up our game a little bit.